friends, how are you? Today we are going to learn mathematics with Mr. Okori Jacob, and the topic we are going to look at is length, mass, and capacity. This is something so big we can't look at it today, so we are picking a smaller part from length. From this length we are going to look at how to find the area of a square. And I believe at this point we need to know what a square is. There I mean we define a square. A square is not something new to you, I know. So a square is a quadrilateral which has equal sides and angles. Let's repeat this. We are saying a square is a quadrilateral which has equal sides and angles. That's what the square is. Now, this keyword we have here is quadrilateral. It's a big word, simply meaning a general name for all four-sided polygons. All polygons which have four sides are called quadrilaterals. Now here we are looking at only one of them, which is a square. So before we go and get area, let's also look at the properties of a square. What makes a square unique from other quadrilaterals? The specific features that it has. So we're going to look at properties of a square. Some of these properties are already in our definition up here. One of the properties of a square is that a square has four equal sides. So when we are going to talk about that, let's also have a square drawn. So I've said our property number one, a square has four equal sides. Now in our diagram here, to show that all sides are equal, we have a symbol we can put in our diagram here. To show that all sides are equal, this kind of mark. To show that all the sides of a square are equal. That is our property number one. Property number two, a square has four right angles. The square has four right angles. Now, a right angle is an angle of how many degrees? It's an angle of 90 degrees. So we can also show this property in our square. It has 4 right angles. So each vertex here can indicate a right angle. The other property of a square is that it has diagonals. Just do the diagonals. So diagonals meet at right angles also, and they bisect each other. I say each diagonals bisect each other at right angles, and I believe you know what right angles are. So these ones run across our square. Our first diagonal is there. Our second diagonal, we have it there. So we are saying that they bisect each other at right angles. Our last property talks about lines of folding symmetry. So I would like us to come up with the square. You can come up with it using a piece of paper. But let's look at the one that I have here, which is a square piece of paper. We want to come up with lines of folding symmetry. Meaning we can fold this square to come up with lines. And when you fold, make sure that we don't overlap. Our folding will not overlap. So when I fold this along this diagonal, this other part will come and fit exactly the other part without any overlapping. So this will give us a line of folding symmetry. Then if I have it along the diagonal, I can also have on the second diagonal. I fold it, making sure that it does not overlap. Now we have our second line of folding symmetry across the diagonal. Now so far we have 1 and then 2. But we can still get more. We fold our square piece of paper vertically. So when I fold vertically, remember, you don't overlap. There's no overlapping. So we now have another line of folding symmetry, which is vertical. And finally, we can now fold horizontally. After folding horizontal, we can also come up with a line of folding symmetry. Very first, let's count the lines we have for folding symmetry. We have 1, 2, 3, and then 4. Therefore, that fourth property of the square, you can write it as a square has 4 lines of folding symmetry. So those are the properties of a square. Now, at the beginning, we was looking at how to get the area of a square. So for us to get the area of a square, then we need to know the formula of finding the area of a square, which I believe some of us know. Now here, we are going to look at that with examples that we have here. These are our examples we're going to look at to find the area of a square. Now, the question is find the area of each square below. We have the first square here. We've been given the measurement of this side. Now we are supposed to start with the formula to find the area of a square. Anyone to give us a formula? Our area is equal to side times side. Because all sides are equal for our figure here. So side times side is the formula we're going to use. But we need to continue by doing substitution, replacing these sides by the value given in the square. Each side is 8 centimeters. So here when we multiply 8 by 8, we shall get 64. When we square multiply centimeters by centimeters, we get square centimeters. So which means the area of this square is 64 square centimeters. Our next example here, the measurement is a decimal. But remember, we always have to start with the formula. Our formula is area of a square is equal to side times side. Each side here is 1.4 decimeters. So we substitute 1.4 decimeters times 1.4 decimeters. When we have a decimal fraction, we have to convert it to a common fraction. So 1.4 as a common fraction is 14 out of 10 decimeters times 1.4 converted to 14 out of 10 decimeters. Now we have a task of multiplying numerator by numerator, then a denominator by a denominator. 14 times 14, let's work it out together. So when you have 14 times 14, what shall we get? 4 times 4 is 16. So write 6, we regroup 1. Then we multiply 4 times 1, which gives us 4 plus 1, which gives us 5. Then we multiply 1 times 4, which will give us 4. But we are multiplying by indicating in place of tens. So our answer will be in tens. Write it under tens. So write 4. Then 1 times 1 gives us 1. So now we add this. 6 plus 9, which we can take as 0. So 6 plus 0 gives us 6. 5 plus 4 will give us 9. Then finally here we have nothing here. We can take as 0 plus 1 give us 1. So when we multiply 14 times 14, we get 196. This is now out of our denominators. We have here 10, and then also here 10. We have to multiply a denominator by a denominator. 10 times 10, we shall get 100. Now, decimeters times decimeters will give us square decimeters. Now, our question here was a decimal. We had a decimal in our question, so our answer also must be a decimal. So how do we convert 196 out of 100 to a decimal fraction? Remember, we have two decimal, we have 2 zeros in the denominator. Our answer must have 2 decimal places. And we arrive at that, we assume a decimal point is here, we move it to the left-hand side. Each time we move a decimal point, we cancel the zeros. Move it one step, cancel 0. Move it for the second time, cancel the 0. We have cancelled all the zeros, so we can write our answer. Our answer becomes 1.96 square decimeters. This is our answer for example 2. Our last example is here. Calculate the area of a square table whose side is 1 3/4 meters. So here we have been given a question in one form. So it's very good for you to first interpret using the diagram. We draw a square. Remember to indicate our properties. So each side of this square table is 1 3/4 meters. Next thing now, our formula. The formula is area of a square is equal to side times side. Each side is 1 3/4 meters times 1 3/4 meters. When you have mixed numbers like this, we are supposed to convert them to common fractions. And I believe you should be knowing the formula. It's going to be our denominator times whole number plus numerator out of denominator. Our denominator here is 4. We are going to multiply it by the whole number. After that, we add. 4 times 1 is 4. 4 plus 3 will give us 7 out of 4. Our units remain is meters times. The same thing here. We multiply the numerator times the whole number plus numerator. 4 times 1 is 4. 4 plus 3 give us 7 out of 4 meters. This is taking us back to what we did with example 1 part B, multiplication in fractions, whereby you multiply the numerator by the numerator. Now 7 times 7, what do we get? We get 49 out of denominator times denominator. 4 times 4 will give us 16. Meters times meters gives us square meters. Now, this is a mixed number. So our answer must also be a mixed number. So we convert an improper fraction to a mixed number. If this is a little bit challenging, you can come up with table 16, which can help you convert a mixed number. To convert an improper fraction to a mixed number. So we want to multiply 1 times 16 will give us 16. 2 times 16 gives us 32. 3 times 16 gives us 48. 4 times 16 will give us 64. Now we are looking for a number which is exactly 49 or almost 49, but shouldn't be more than 49. So if you look at our answers, 16, 32, 48, 64, which one is nearer 49? I think we all find out that it is 48. Now this is going to help us get our answer. So we are going to reduce by 16. 16 divided by 16, we get here 1. Now 49 divided by 16, look at this carefully, we shall have 3. So 16 goes to 49 3 times. Then we have a remainder. To get a remainder, subtract 49 minus 48 to give us the remainder as 1. So our answer will be 3 whole number, 1 out of 16 square meters. Something to note here is that when you're given each side as a mixed number, your answer also must be a mixed number. If the question you're given a decimal fraction, the answer must be a decimal fraction. If we have a whole number in our question, the answer must be a whole number. I believe this has been a good lesson. You've understood. Remember to write your comments in the comment column. Have been Teacher Jacob Mukore. The activity, you're going to find it after this video. Thank you so much for listening.